All right, so I have started the stream and the format is going to be pretty simple. I'll just name the topic and you will give me brief information or elaborate information, right? Whatever is needed for me to understand. And also at the end of the chart, you will give me some questions. I will try to answer those questions and then we will get a solid grasp of what the topic is about. So our first topic is mathematical logic. Let's get started. All right, mathematical logic is the study of reasoning and inference. In GATE, it is mostly about propositional logic and predicate logic, plus methods to prove truth or falsehood of statements. Propositional logic, a proposition is a statement that is either true or false. It is right. Logical connectives, negation, conjunction, disjunction, implication, biconditional. We use it to evaluate all possible truth values of a given logical expression. P implies Q. The only case where it is false is when P or P is true and Q is false. Tautology, contradiction, contingency. Expression always true is called tautology. Expression always false is called contradiction. Sometimes true, sometimes false is known as contingency. Logical equivalence and law statements can be simplified using equivalence law, like De Morgan's law. We have double negation law, conjecture normal form, end of words. Okay. So what is conjunction? Okay, there is an between P and Q, and then it will be connected by or. And disjunction. Okay, sorry, conjunction. Yeah, conjunction means and disjunction means or. Okay. Sad solving and proof techniques. Predicate logic extends propositional logic is quantifiers, universal quantifier, existing quantifier. Right, for all x greater than 0 and x greater than 0. Modus ponens if p plus q and p, then q modus ponens if p plus q and negation q, then negation p. Contrapositive proof, direct proof, and proof by contradiction. Okay, there are. Okay, you are supposed to try these questions now. Construct the truth table for 3. Yeah, we will go in this way only. So P implies Q or negation P. We are supposed to construct a truth table for this. So we got P, we got Q, we got negation P, Q or negation P. P implies Q or negation P. T, N, T, F, and F. So negation P will be F, T, and D. So Q or negation P, you need to do an OR for this. It is true, it is false, it is true, and it is true. P implies, right? T is T, F is F T is T, and F T is T. So false at TF case. Okay, and tautology, we need to check whether if it is a tautology or not. P implies Q, or Q implies P. We got P, we got Q, we got P implies Q, and we got Q implies P, and we got P implies Q, or Q implies P. Same thing, T, 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 F, F, T, F, F. So the P implies Q will be T, F, T, and T. The Q implies P will be T, T, F, and T. So an OR for this will be T, 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 T. As it is a tautology. Right, things are going good. If it rains, then the ground will be wet. So P implies Q is the statement and the contrapositive is negation. P implies negation, Q implies negation P. So if the ground is not wet, then it didn't rain. That is the contrapositive of the statement. If this is true, this is going to be true as well. So you got to convert it to CNF negation of P or Q implies R, or you convert it to CNF form. So CNF conjunctive normal form, conjunction is like R, sorry, conjunction is like N, so it is this form, right? That means A or B and C or D, something like that. So what you do is first you remove the implication using the implication law and negation of negation P or Q or R, that will be just P or Q or R. Uh, so is this, yeah, I think this is the required min term, is it? Yeah. This was the statement in predicate logic. Every statement in the class passed at least one exam. Every student in the class passed at least one exam. So every student in the class, for all x, if x belongs to okay s of x how to represent this in predicate logic. So student, let's say s of x passed at least one exam. So p of x passed exam. So it's not at least one, you can say passed one exam. So that's p of x, right? Or sorry, this is the symbol of there exists. God. For all x, s of x, there exists p of x. All right, so I'm going to say the answers. The first one got everything true except for the TF case. And for the second question, it is a tautology with the truth table construction. So the contrapositive of the statement is if the ground is not wet, then it did not rain. And for the fourth statement, I got P or Q or R. I think that is the only min term that you will get after simplification. And to express the statement in a predicate logic, let's say the student is S of X and past exam is P of X. So for all X S of X, there exists X P of X. Is that how it works? I don't know if it is able to comprehend that, but let's see. Yeah, the TF case is false, okay. Tautology 100% correct. Implication chain tautology, okay. Yeah, if the brain. No, I said P or Q or R, but that's fine. So for all X, S of X implies there exists Y. Okay. So I'll just write this down. For all X, S of X implies there exists Y, A of X comma Y, right? So X cannot be used for exam and student. All X and X is the student of class, then there exists at least one student who passed exam Y. So if and then if then means implication. So for all X, S of X, then there exists if and then. So implies there exists Y, there exists an exam such that the student has passed the exam Y. Right? So you need to use two variables here and it's all right. 1 hour, 1 minute, and 1 second. What do you mean? Oh my gosh. All right, so let's get started with the next topic. Let me just get my book. The next topic is set theory and algebra. Just list the important topics and then ask me some questions. Let's see how much I have gotten through that. All right, set theory and algebra. Representation, roster form, and set builder form. We have known that finite, infinite, empty, singleton, power set, and universal set. I think we know that union, intersection, difference, complement, class of sets, ideal code, formula, associated, distributed, Morgan's laws. Yeah, we know them. We know Venn diagrams for solving two set and reset problems, cardinality, the number of elements in a set, inclusion, exclusion principle. It was just stated by us yesterday. It was just stated by a teacher yesterday. And relationship between the sets include, I don't know if anyone's watching the stream, but let's see. Yeah, I think no one's watching, but forward to pop up today. It was just stated by a teacher yesterday. And relationship between the sets include, okay, algebraic structures. Okay, algebraic structures. A star is a binary operation. It can be anything closure explicit. Okay. So semi-groups with closure. Boloid. Okay. I think we are supposed to know that. Instead of that, is a group. I need to understand what a group is before. And every group is a monoid, but not every monoid is a group. And I also need to know the Boolean algebraic simplification to test to pass these practice questions. But let's first write what what we know. A union B for that set is 1, 2, 3, 4, and 3, 4 is already there. So 5, 6 is the union, and the intersection is common. So we don't have 1, we don't have 2, we have 3 and 4. And A minus B are the elements that are present in A but not in B. So 1 is exclusively present in A, 2, but 3, 4 are present in the B as well. So A minus B is 1, 2. Using exclusion principle, so 100 students, we have 45 math, 50 physics, so 20 like both. Okay, how many? At least one subject. Okay. Uh, so A is the number of students who like math, B is the number of students who like physics, and A intersection B is the number of students who like both. So total number of students are A union B, A plus B minus A intersection B, right? What are we even trying to calculate here? 45 plus 50 minus 20. That is 95, 75. Okay, 75 is the number of students who like at least one subject. I think that is determine what is a group in such theory. A group is a set provided, defined as a set provided with a binary operation that combines. Okay. Long time since I have seen this site. Or group. And so, okay. Solving directly GATE question through just give you a headache and shall we are trying from the very basic level. Directly star closure associative identity element and a noise element. Set of integers. Okay. Set of integers under addition is a group. Set of okay, that is our question, I see. So a group follows these four properties. A group four properties. Closure, associative, and what else we got? Identity and inverse. So Z under addition, the set of integers under addition, there should be, I don't know, closure. A Z plus Z will be a Z, and A plus B plus C will be A plus B plus C, that's true. And A plus 0 is equals to A, that is identity element, and A plus minus A is equals to 0, so that is the inverse. Okay, this is working. Okay, under multiplication, Z into Z is equals to Z, true, and ABC is equals to ABC, true, and A times 1 is A, and A times 1 by A is equals to 1. Right, so these are groups. Every group is a monoid, but not every monoid is a group. So first we got to know what is a monoid. What is a monoid? Monoid is a set equipped with an associated binary operation and an identity element. Okay. Associativity and identity element. Associative and identity is monoid. So group is like bigger thing. Monoid means, monoid is smaller group. Group is a bigger group. So every monoid is a group, but that is right. Every monoid is group, but every group may not be. What am I writing here? Yeah. Okay, group is like the bigger thing, right? Every group is a monoid. Yeah, because group has more criteria. Every group is a monoid. True, but every monoid can be group, because if it is associative and not closure, it can be a monoid, but it cannot be a group. Okay. Express this in set builder form. So what is it? Set builder form. It is just a way of representing even numbers. Right. For all x such that x belongs to 2n, where n belongs to capital N. That is how you write it. I think Boolean algebra simplification. A times A plus B. So Boolean algebra A times A plus A times B. right? You can apply the distributive property or of multiplication or addition, I think. Okay. You can do this as well. A or B. A and A, or I mean, if you are comfortable with these symbols, you can do this. So A and A is always true, true or A and B. So that is A and B. That is it, right? So I got the union of elements as 1, 2, 3, 4, 5, 6, and the intersection as 3, 4, and the difference as 1, 2. And the inclusion exclusion principle, I have just applied it and I have got 75. And for the third question, both of them are groups because they are following all the four properties: closure, associative, identity, and inverse. And for the fourth question, yeah, that is a true statement. Every group is a monoid, but not. I mean, but every monoid cannot be a group because if the set of elements follow associative property but not the closure property, then it can be a monoid, but it cannot be a group. And for the set builder form, for all x belongs to 2n, whereas n is a natural number. And I have simplified that. I got a plus b. I mean, sorry, ab, right? I got a and b. Okay. Okay, it is thinking longer because I have given a longer phrase. This session is going amazing, to be honest. Good attempt. Still do. Still teachers do not have a multiplicative inverse. Okay. By 2 or 1 by 3 is not an integer. So not closure. Got it? Abelian group. Okay, this is called is a group called abelian. Yep, nice. Every group is a monoid. The reason needs a tweak. But what is a monoid? Associative identity. Okay, lacking in node size. So lacking in words defines if it is just a monoid or a group as well. That okay, A plus AB. Okay, we need a Okay, I mean A plus AB. Okay, A and A is not true. A and A is A. A plus AB is A. What do you say? A and A is A. It is not true. That is where we did the mistake. So it's 30 plus 25 plus 20 minus 12 minus 10 minus 8 plus 5. So this is 45 and 75 minus this is 20, 30 minus 30 plus 5. So 75 minus 25, that is 50 is your answer. And stay true or false with reason. Every finite semi-group with cancellation loss is a group. Every finite semi-group with cancellation loss. What is a semi-group? Uh, I am trying to speed run. Closure and associativity. Every finite semi-group with cancellation loss is a group. What are cancellation loss? Okay, we are digging Okay, we have understood what a semi-group is. We have covered shirt. The only yeah, dude. A plus B times A plus C to a minimal form. I think we gotta use the distributive law here. We'll treat this as one term first, A plus B times A plus B times C. And we will use again the distributive law, A plus B plus AC plus BC. Right, this works. A plus BA plus AC plus BC. Okay. A is just A plus AB plus AC plus BC. So A plus AB is A plus AC plus BC. A plus AC is also A plus BC. Is this simplified to A plus BC? No. So for the inclusion and exclusion principle, I got the answer as 50 for using the formula of three sets, and I didn't understand the second and third questions. You got to explain me. And for the fourth question, I got A plus BC. Mm-hmm. In a finite set, if cancellation law, solution laws is a group. So what is a semi-group? It follows closure, closure and associativity. Cancellation laws. AB is equals to AC, that means B is equals to C. There exists an inverse. A got cancelled because A inverse exists, right? We got it. So it is a group. And there is environment. There is identity as well. Okay, monoid. It is closure. It is associative. It has identity. Set with union is a monoid. Hmm. It's saying that power set is set of all subsets, right? So this is more difficult than expected. So how is it closure? Yeah, A union B is a set of power set. Okay, that's why we're saying union, right? Associativity applies to union. So identity, yeah, null set is a okay. This is not it. Sorry. Yeah, I mean I don't need. I shouldn't put the brackets over here. Is identity element. Inverse is not guaranteed. So it is just a monoid, not group. Cool. All right. And identify the structure it takes. And it's sure. Uh, General when closure one of two will be answer. Associated minimum change no matter how you take it. Identity that should be set value such that it always returns minimum when return with another number. So we need to have a maximum of integers. Which doesn't exist. So there is no identity so it is just a semi-grid. And for the Q, except 0 with the multiplication operation, closure is associative is identity into 1 is equals to y for any q inverse exists except for 0. So it is a group. So So just a speculation, you cannot say whole numbers are group, right? Let's say whole numbers under multiplication. Yeah, they are closure, okay, and they are associative. And the identity element is 1, but the inverse doesn't exist because the whole numbers include 0, right? Okay, so non-zero happening, non-zero rationals given again. His studies on his own. Integers under relation, yeah, they are closure, they are associative, and they have identity element which is zero. Yes, it is a group because there is closure property satisfying, associative property satisfying, identity satisfying. Just plus zero of anything is zero. I mean the same number, and inverse plus z will be minus z, but it will not be a group under multiplication. Yeah, we have already had this question before. Oh, the TTS converter is just great for merging putting. So no, actually the the third topic in our list is combinatorics. So let's just follow the same principle that we are following. Give me brief theory and ask me questions. I'll try to understand and answer them. Topics. Solution to right. Permutations. Yeah, order doesn't matter. Circular permutations, functions. Gosh. Pigeonhole principle. Yeah, I think we should spike on that. So 9 factorial by 9 factorial. So 9 into 8 into 7 into 6. 8 into 64 and 9 into 72. 4 2s are 8, 7 2s are 14, 29, this is 4, 8 and 4, 12, 10, 3024. How many ways to select a committee of 3 members? From 10 if order doesn't matter. So order doesn't matter means that is a combination and factorial. Okay, from 10, there are 10 people actually. Right. N C R, N C 3, N factorial by N minus R factorial, that is 7 factorial into R factorial, that is 3 factorial. So that is until 7 it will get cancelled out. Okay. 10 into 9 into 8 by 6. This is 3 table 2 times, 3 table 3 times, and this is 2 table 5 times. This is 15. 15 eights are 120, right? A necklace is to be made using 6 distinct beads arranged in a circle. How many distinct arrangements are possible? The rotations are considered the same, reflections are not considered. Okay, so what is the formula for circular permutation again? N minus 1 factorial. N minus 1 factorial. Circular. I mean, the gate is not going to ask you questions this easily, but you should be able to solve these questions. 5 factorial. Right, 5 4 the 20, 23 the 60, that is 120, right? Find the coefficient of x power 5, y power 3, and x plus y whole power 8. Coefficient. How to find the coefficient? Kenneth is people are abstracting and
In this video, we're going to focus. So what we're going to do is FOIL the first two terms. Term is going to have a coefficient of.
Well, welcome back. The title of this lesson is called the binomial that gives all these coefficients and all of these terms. Most books are just going to throw it at you and say, here's the binomial theorem, and go off and tell me what a plus b to the 10th power is. The problem is, if you don't know how to use the thing, then it's hard to do those difficult problems. So what we are going to do is break it apart, talk about it, and then we're going to solve these two simplest problems you can possibly have using this, so you know exactly how to apply everything. And in the next lesson, we're going to crank up the complexity a little more. First of all, what does this thing mean, okay? I want you to basically, for a moment, look at the big picture, okay? This part, okay, I don't want to put parentheses, I don't want to clutter it up, but all of this stuff in here, so I'm going to say from here all the way to here, this part
we compare. I see. Running the term here. Okay. So a power 8 minus 5 and what? No, actually minus k is equals to 5 and k is equals to 3. So n is equals to 8. Right, 8 minus 3 is 5, yeah. Actually, it's 3 here, and this is 3. And all you gotta do now is 8 factorial by 8 minus 3 factorial times what is the value of k? 3 factorial, 8 factorial by 5 factorial times 3 factorial, so that is 8 into 7 into 6 by 6. That is 56. So this is as simple as that. Right. So I have solved the problems and the first thing came to be 3024 after solving a simple permutation. And for the second one I got 120 and for the circular permutation I got 120 as well. And for the coefficient problem I got 56. And also proving by the pigeonhole principle is easier, right? Because there are 13 people and there are only 12 months. So at least 2 people have the same birthday month because there are only 12 possible cases, but there are more number of people than the possible cases. Hmm. So, oh my god. So, right, it's been an hour. I think I will take a break.